Today we're going to continue our study of polar graphs. To do this, we're going to use our calculators. So if you look at this equation right here and this equation right here, I want you to plug those into your calculator, and then we're going to copy them to our graph and we're going to observe them. So here's my calculator. Notice how I put 2 plus 3 cosine theta at the top. It's highlighted. I'm going to graph it. And notice how it kind of looks what we talked about last class. It looks like a cardioid, except you have a little loop in there. So we're going to copy that graph down. So I have a point at 5, 0, point at 0, 2, origin, 0, negative 2, and 1, 0. I'll just verify to make sure that's right. Okay, now let's graph it. Do your best to try to make these round as possible. So let's try to copy your calculator screen. Okay, so something like that. So there's our first graph. And to make a chart, I'll quickly make an r theta chart. We can see we'll use 0, pi over 2, pi, and 3 pi over 2 as our regular points. Right here we can see we are 5 units away, so put 5. You can also just plug in 0 right here. At pi over 2, right here, we are 2 units away. Pi is tricky. This is going the opposite direction. That's going to be, plug in pi, you get negative 1. And then plug in 3 pi over 2 here, so that distance is 2. So let's label that. 1, 2, 3, 4. 1, 2, 3, 4. Now let's go to the other one. 3 plus 2 cosine theta. So pretty similar, except notice how there is no loop there. Interesting. So let's copy that down. So 5, 0 is still there. There's this 0, 3, 0, negative 3, and that appeared to be negative 1, 0. Let's double check that. Yep. And let's copy the graph down. And again, do your best to make these as round as possible. So that's not great, but that's okay. Let's try again to make it a little more round. That's a little better. Okay, so there's our graph. And again, I'll make my chart here. R theta. And I'll do the same things. I'll do the quadrantals. 0, pi over 2, pi, 3 pi over 2. This one we can see is 5. I can see this distance is 3. This distance is 1. And this distance is, once again, 3. We'll label that 1, 2, 3, 4. Now at this point, we've copied the graphs down. I want you to take a few minutes, pause the video, and try to go through all the questions below, all these questions, A, B through E. Once you're done, unpause the video, and that's when I'll talk about the answers. Okay, hopefully you've looked through B through E and you've thought about it. The answers are going to be, what's the difference between graph number 1 and graph number 2? Well, a couple things. Number 1 has a loop and hits the origin. Whereas number 2 does neither of those things. And that happens because of this point right here. Number 1 has the potential to be negative, so this negative value creates the loop. Whereas if you look at this one on the right here, this has no potential to be negative. There's no possible way to make this expression negative, and you're seeing that right here, which means it will never loop. It can't even hit the origin because this thing can never be 0. So for example, if you actually wanted to find this point, we actually could. Let's say to solve it, I could say 0 is equal to 2 plus 3 cosine theta instead of r. Notice how I'm making r is 0 because that's when the origin point would happen. Solve that. So cosine theta would be negative 2 over 3. And at this point, we need to calculate. We have to figure out what angle this would be. But for now, I'll just write it as the point would have to be 0 cosine inverse of negative 2 over 3. So that would be this origin point right there, if you wanted to actually find it. Okay, so that's letter B. The main thing is, again, to notice that number 1, this first one has a loop, hits the origin. This one does neither of those things. Next question. If the form is a plus minus b cosine theta, what happens when a is bigger? What happens when a is less than b? Okay, so if a is greater than b, so look up here. If the first number is bigger, there is no loop and no origin point. If a is less than b, it loops and hits the origin. And again, that's because it has the potential to be negative. So all right, can be negative. How are A and B related to max and min? That one's not too bad. Essentially, just add them. So to be proper, I'll write the absolute value of A and B. To add them, you get the max. You subtract them to get the min. Now, what would happen if we change a plus to a minus? So hopefully you just checked in your calculator. For this particular example, it would reflect over the y-axis. If we made it sine, it would have up and down orientation. Or you can think of it as having y-axis symmetry. Okay, so those are the discussion questions. Hopefully, as you're going through this, you kind of hit some of those points. A little bit of reading here. These graphs are called limaçons. So right here, that's a French word. And limaçons are characterized by equations of the form right here. A, B, some plus or minus, cosine theta, A, B, some plus or minus sine theta. A is typically positive, but you can play with that. To make it easier, I'm just making all of them positive for this worksheet. So right here are some examples of limaçons. And notice how this middle one, this is a cardioid. Which means if I were to make a diagram, cardioids are right here, and limaçons are like that. Meaning all cardioids are considered limaçons, but not all limaçons are considered cardioids. And I'm going to show you two more examples. We're going to create the equations here. The first thing you want to do is always write r equals, never forget that. And I want to show you a couple of things to think about. The first thing I want you to think about is this going to be a sine or cosine? And we can see that it's oriented to the right, or has x-axis symmetry. So in this situation, it's a cosine. So I'll write cosine theta. The next thing you want to think is it positive or negative? In this one, we can see it's oriented towards the positive x-axis, so it's positive, so you put a plus right there. And the last thing you want to find is your A and B value. So essentially, in this one, I'll make it even easier. You want to figure out this number right here, this A. So I'll write find A, and that's going to be the intercept. Intercept meaning like these points right here. So in this case, it's 3. So 3. And then notice how this is actually a cardioid. So we know this to be 3. That's what we did last class. But another way you could do it is figure out, let's say you didn't know what that is. You can see right here the max is 6, And we learned that if you add a and b, you get the max. So 3 plus b must equal 6. So b must be 3. That's a more complete way to practice this. So I'll do one more with you. R equals, I can see that it's sine, because it's going up, and it's positive, so I write positive sine theta. The intercept value is right here, so I'll write 2. And notice how the max value here is right here, that's 6. So think about it. 2 plus b must equal 6. b must be 4. So there's your equation, 2 plus 4 sine theta. Okay, so good luck on the rest of the worksheet, and bring your questions to class.